Hi, it's Tom again, and in this video I'm going to talk about the class library that is going to be used to support ultimately my user control that I create. So this class library deals with playing cards and decks and hands and that kind of thing. So these are the classes and enumerations that can be found in my library. Starting from the left, we sort of go from basic to more complex. We have an enumeration for the card rank, so ace, 2, 3, 4, all the way up to joker. We also have a card suit enumeration, spades, hearts, diamonds, clubs. The order that I put those in, by the way, are the same order that the Unicode characters for spades, hearts, diamonds, and clubs exist. So these two enumerations are used, they're contained within the playing card class. So the playing card class is probably where we're going to be focusing most. You can see that the playing card class supports, or implements I should say, two different interfaces, iClonable and iComparable. So clonable, I decided to implement in the playing card class because conceptually I knew that the playing card objects were going to be put into different types of collections. So a deck or a hand or a shoe are all collections of playing cards. So if I want to do deep copying in any of those other classes, then the playing card should be clonable. iComparable is useful as well in other classes where I want to do sorting. So for example, in the hand class, which is a collection of cards, there's a sort method. So to do sorting easily, without having to write my own sorting algorithm, I support or implement the iComparable interface. So my playing card class has a number of different properties. The card value, so how much the card is worth, whether it's face up or not. It has a rank, it has a suit, and I haven't actually implemented this in any programs yet, but there's an alternate value. The concept there is that there might be some card games where a playing card might have more than one value in certain circumstances. Many games won't implement this, so this is actually, I've implemented this as a nullable parameter. We'll talk about that when we look at the code. There's a bunch of different methods. Obviously, there's a constructor. Okay, so when I create a playing card in the first place, there is a whole pile of different overloaded operators for the relational operators. Not equals to, less than or equal to, greater than or equal to. So when I'm comparing two cards, and these are fairly consistent, I'm comparing based on the actual value. There's overloads from system object. Get hash code, which basically gives you a unique integer that represents the state of the object. So converting your playing card, if you will, into an integer. So we'll talk about that. That's actually necessary to override system objects get hash code in order to overload your equality operator, and that's explained in the chapter, I think, for collections. We also overload the toString method from system object, the toString method there. And in the context of a playing card, what that string will actually do will be basically the name of the card. So Queen of Hearts or Red Joker or whatever it is. Playing card objects are used in three different types of collection classes. I have a deck class, which represents a read-only collection of playing cards. Essentially, what the deck class does is it initializes the deck, a deck of cards. So let's say you're 52 cards or 54 cards, whatever it is, based on some parameters. It creates the collection and initializes it to some default values. It's not the intention of this class. It wasn't my intention to actually deal cards directly from a deck. What the deck class is primarily used for is initializing a card dealer object. The card dealer class is a class that is used to represent almost like a blackjack shoe, if you know what that is. It's a device that you load decks into, decks of cards, and it you shuffle the decks, you put them into the card dealer, and you draw cards one at a time from the actual shoe or card dealer. So you can see there's a number of fields here. There's what deck I'm going to be using to initialize the card dealer. There's a number of decks field and property. And then there's this thing called a red card position. Well, I'm not going to implement that in any of the programs I'm going to show you, but it's something for a blackjack shoe. Basically, they insert a red card into the pile at a certain position, and once you get to that red card, you have to reshuffle all the cards and put it back in the deck. Any rate, you can read more about blackjack shoes online if you like to. The key properties of the card dealer is we can find out how many cards are remaining in the card dealer. We can find out whether the card dealer is empty. We can find out how many decks were loaded into the card dealer, whether or not we've reached the red card. And I also have some methods, a couple of different constructors. I have a clone method for deep copying. A draw card method is the main method that we're going to use for the card dealer. Load the card dealer, which I use for loading it initially, as well as reloading it if I need to, as well as a shuffle method to shuffle whatever cards are currently in the card dealer object. So the next collection class I have is the hand class, which represents like a blackjack hand, for example. Also a collection of playing cards. So the idea is that we add cards to the hand. Okay, here's the add method that we draw from the card dealer. So that's kind of the relationship there. Okay, it too has obviously constructors. The main methods of the hand class are add and remove. It's also clonable, and I have the ability to sort the hand class so that when I'm displaying the cards, they're displayed in a particular order, or may be displayed in a particular order. So the card dealer has the ability to draw cards, either individual playing cards, like how we do it in the game of war that I showed you, or I can draw cards into a hand, which would have multiple cards. So that's the basic overview of the classes that are found in the Tom Cards library. So we'll quickly look at the enumerations. Okay, so I have my card rank enumeration. Okay, fairly straightforward. Okay, nicely commented. I like to comment my stuff, include some links and that sort of stuff if I need to. The underlying type of card rank is a byte. I want my ace to start off with the value 1, and then every subsequent enumeration item in the list here is going to be 2, 3. It's going to increment each time. These numbers are actually kind of important for me because I use the card rank in determining the value of the card. So I need to be able to sensibly convert them into integers if I need to. Next up is card suit. Nothing really surprising here. We've seen this kind of thing before. Also underlying type of byte. I was a little bit less concerned with starting it off at 1, so spades is actually converted to 0, and that's fine for my purposes. Next up is the actual playing card itself. So a little bit more involved in this class. I've got a number of references there, particularly to the iComparable and iClonable interfaces. Most of you know what a playing card is, so you probably don't need to check that out. I'm going to get back to this attribution in a few minutes, but the basics of it in this library, I've used some card images that were created by somebody else. So following their directions on the appropriate use of those images, I've included some attribution here. And of course, if I distributed any applications that, or the library itself, I would include that in the appropriate readmes, etc., manuals, that sort of thing. So I've just collapsed some of my regions here, but I want to talk a little bit about keeping your code neat and tidy. You can see here I've only got 2 using statements, so I've removed the ones that I didn't need. Systems drawing actually was one that I didn't get by default when I created my project, and I had to add a reference to the project to be able to putting the using in just didn't do the trick. So just to review how we actually do that, if you go into your Solution Explorer, go to your project and add a reference, okay? Go to your assemblies. I just simply typed in drawing here, okay, and selected system drawing from the list that came up. I've already included it, so I don't need to say okay here. The reason why I needed to include system drawing is because in this class I refer to images, and images are defined in the system drawing namespace, so I needed to include that assembly. So the class itself in the TomCards namespace here is a public class. Obviously, I want to be able to use it outside of this project. It implements the iClonable and iComparable interfaces, and we'll look at the methods that are needed to implement that. And I've just sort of tried to keep things organized into 4 different regions. So I have my fields and properties, I have my constructors, my public methods, and then I also have a section of relational operators. Let's look at the fields and properties first. So a card has a suit and it has a rank. Okay, so I have 2 protected fields and public properties, suit and rank, or my suit and my rank if you're looking at the fields, and the ability to set or get either of those things. So that's pretty straightforward. I have a value set up very similarly, except that it's an integer used to set or get the primary card value. The alternate value, you'll notice, has this question mark in it. Okay, so question mark means that it's a nullable type. Not every time I use a playing card will the playing card actually have an alternate value. So rather than just set it to some arbitrary number like -1 or 0, which in a particular game, I don't know, maybe there is a card that's worth -1 or 0. So I want to avoid that type of problem. By default, the alternate value is null, I should say, meaning that it doesn't have a value, as opposed to setting it to 0 or something like that. So in certain cases, that might be useful. There's a face-up property. By default, the face-up property is false, and again, sets and gets the face-up property. So those are the various different properties and fields. Next, we'll look at the constructor, singular in this particular case, for a playing card. Okay, so we want to initialize a playing card when we first create it. So there are a couple of parameters, the rank and the suit, and I have default arguments for each one. So by default, if I create a playing card object and I don't specify what the rank and suit is, I get the ace of hearts. Why the ace of hearts? No particular reason. So I simply set the rank, my rank, and my suit fields to rank and suit. I could have used the properties instead. This is optional. And then I determine what the value is. Now the value of the playing card is going to be different depending on the actual game I'm playing, and I can't anticipate all the various different ways that somebody might want to set the value. However, I want to give the value property a default value to start off with. So what I've done is I've just taken the rank and I've converted it to an int. Okay, so the ace will be 1, 2 will be 2, 3 will be 3, all the way up to 10. Jack would be 11, and so forth. Let's take a quick look at the relational operators. I'm a little low on comments here, but these are pretty straightforward, and I think right out of the tutorials that you've already done. So I've created operators for is equal to, not equal to, less than, greater than, oh sorry, less than or equal to, greater than, and if I scroll down, I see greater than or equal to. So in a lot of different games, I'm going to be comparing cards. So what does comparing a card mean? And I've defined it in this class as comparing the values. So in each case, whatever operation I'm doing, I'm essentially returning the result of that same operation on the card value. Okay, I could have used my value there as well. It doesn't really matter. Okay, so those are my relational operators. Next up are my public methods, and there's a few of them. The first one we'll talk about here is CompareTo. Okay, so CompareTo is a method that I need to implement in order to support iComparable. Okay, there's a bit of code in here, and certainly you can look at the MSDN reference on the iComparable interface to get a little bit more information about this. But essentially what this is used for is in my hand class, I want to be able to sort the cards. So how do I want them sorted? There's suits. Do I want to sort them by suit, or do I want to sort them by rank, or whatever? What CompareTo does is it will actually use this when I try to put it into, let's say I have a collection of cards like an array list. If I want to sort them, I can just use the sort method, and it will actually utilize this CompareTo when it's determining the sort. So CompareTo is used for sorting. It takes a generic object as a parameter. So inside my CompareTo, I filter out if the object is null. If the parameter that is, or sorry, the argument that's sent to this is not actually got an instance attached to it, then I throw an exception. If that didn't happen, then what I do is I convert the object into a playing card. So I've created a new playing card, initializing it with object as a playing card. And then I look at that. If the compare card that I just created is not equal to null, it'll be equal to null if it couldn't actually use object to create a playing card. So this is basically saying if this compare card thing worked. What I want to do is I want to sort based on the value of the card times 10 plus the suit. So what this will do is it will, in the case of Durac, for example, if I increase the value of the trump cards, it'll lump all the trumps together. And then what it'll do after that, it'll sort by suit, which is kind of the way I like it. So I've arbitrarily said that the value is more important than the suit in terms of sorting. So I create two integers, this sort and my compare card sort, and I determine what they are. This basically the using the same formula, and I call the CompareTo method for. Excuse me, I had a bug in my throat there. I call the CompareTo method for the integer, and that's what it actually returns. So it returns, the CompareTo method by default will return either -1, 0, or 1, and it's related to the sort value. Okay, which one should come first in a sort? So that's what that's doing. If the compare card was equal to null, that meant that I have a problem with the argument. I can't convert it into a playing card, so I throw an exception to deal with that. Okay, so that's the CompareTo method. The clone method for a card is very straightforward. Because there are no class types in a playing card, I can simply return a member-wise clone. Okay, so I've just overloaded that, or created that method, and that supports my iClonable, or implements my iClonable interface. Converting the card to a string. Okay, so I'm overriding toString, the system object toString. Okay, so it does something other than the default. I create a card string. If the card is face up, I go through some logic. Otherwise, the card's face down, and the card string is just simply face down. If it is face up, I check to see if it's a joker, because jokers usually will say there's a black joker or a red joker. If it is a joker, I check to see if it's clubs or spades. If it's clubs or spades, it's a black joker. Otherwise, it's a red joker. Otherwise, it's not a joker, and I basically deal with it by saying the rank, 10 or queen or jack, of the suit. And then I get down to the last little bit of my toString. I'm returning the card string, whichever version it ended up being. Another method that I needed to overload from system object was the equals method. This is required in order to overload my equality operators. So public override bool equals object, and basically what I want to do is I want to return whether or not this card value is equal to the object's card value when I typecast it as a playing card. Okay, so that's pretty straightforward. And again, this is explained in more detail in the collections and comparisons chapter of the textbook. System object hash code was another thing I needed to override for similar types of reasons. Basically what the hash code is a unique value, integer value, that represents the state of the object. So I use the same formula I used in my comparer function, where I took the value multiplied by 10 and I added the suit to it. So the state of the card is represented with this equation. Now, technically speaking, I should probably add to this, and maybe I'll do this right now, is whether or not the card is face up or face down. So why don't I do that? So I've just modified this formula a little bit. I'm multiplying the value times 100 now, the suit times 10, and if it's face up, I'm adding 1 to it, and if it's not face up, I'm adding 0 to it. Okay, so again, a unique integer based on the state of the card. Another method I have in this class is a public method that returns an image. It's called getCardImage. So what this method does is it determines, based on the name of a resource in my project, what card image should be associated with this card. It is set up much the same way as my toString method in terms of the logic. Okay, so I have a card image that I'm going to return. I have a string called the image name, and that's the name of my image in my resource file. So I go through, again, the same logic. If it's not face up, that means it's face down. The image name happens to be back. If it's a joker, there's a particular name for the black and red joker. Otherwise, the name of the resource is the suit underscore the rank. Okay, so and then there's this bit for actually extracting out the image from my resources. Now, before we actually do this, let me talk a little bit about how I got resources into this project in the first place. I go to the project menu and I choose my properties for the project. Now, when you first do this, you may not have a resource file, so you may have to click a link here that says create the resource file in the first place. And then when you first look at it, it normally will default to some string resources. What I did was I switched it to images, and you can see I've already got them in here. Yours, if you were just going through this, of course, would be blank. And then I just very simply go to where I have the images saved on my computer. I'll select all of those and I'll just drag them in here. Now I don't actually want to do this because I've already done this. Okay, but that's just a very quick and easy way to get a bunch of image resources into your actual project. Now what that does is it creates a folder in the hierarchy called resources, and all of these images are actually in there. I'm going to close that. I'm going to go back into Solution Explorer, and in my Tom Cards project, if I click on resources, I can see them here as well. Okay, so those are the actual file names, which translate into actual resource names. So the card image that I want to get, I built the resource image using that logic, and then I want to extract it. I go to Properties, Resources, the Resource Manager, and then I use the getObject method. I specify the image name, so that's a string argument for getObject. And then when I'm returning this, I don't want to return it as an object, I'm returning it as an image. Okay, so that basically sets this image object to whatever image it extracts from the resources, and that's what I actually return. This certainly is not the only technique of dealing with images, but it's a fairly convenient one. Now the last method in my playing card class is something called Debug String. And what the Debug String method does is it just displays a string, or it doesn't display it, I should say, it returns a string based on the state of the object. So there's a bunch of things that I wanted to be able to see when I was developing and debugging this class. So what this does is it builds the string based on the rank, the suit, whether it's face up or face down, what its value is, whether it actually has an alternate value, and if it does, what the alternate value is, and it returns it. So again, when I was testing this stuff out, I used this debug string method. Now I've since gotten rid of my testing code because I've tested it a bunch of times already, but I left that in there. It may be useful for later purposes. So that is my playing card class. Your playing card class, if you have one, and I expect you do, may look quite a bit different. Maybe you're going to modify yours a little bit, having seen this video. That's fine. You're welcome to do that, but don't feel that you need to. This playing card class is going to be the underlying class for my user control that displays playing cards. So again, in my library, I have a deck class and a card dealer class and a hand class. Each of these collection classes that deal with playing cards is not going to be directly related to my user control. So perhaps I'll go over those in a different set of video tutorials. So that's basically an overview of what's in Tom cards. Thank you very much.